The bedrock of a healthy and consistent grading workflow is color management. While slapping an input LUT over your footage might provide instant gratification, it might easily deprive it of the much needed details, color, and luma information in the highlights and shadows because of its destructive nature. Using a display-referred workflow where we humans are the color decision factor will leave us at the mercy of our screen-supported gamut and calibration when working with a variety of footage. On the other hand, a scene-referred color management will mathematically compute a consistent color transformation based on the specific camera sensor color space and curve, placing the decision on the software math instead of ourselves. This way, footage from a variety of sources will have a common working color space in our project, where each pixel speaks the same common language. Let's dig a bit deeper about these concepts of display versus scene-referred. In a display-referred environment, Resolve operates on the basis that you are your own color management and defining factor of how your final image should look. This is highly dependent on what you perceive as correct and how accurately calibrated your display is. While you can have a perfectly fine Resolve color grading in a display-referred environment, this method leaves room for quite a bit of color science imprecision, which can result in an inconsistent image from what the camera sensor recorded to what you see on the screen. This further can complicate things when working with different camera sources and trying to match your shots due to each manufacturer's specific color science and gamma curve. For example, the same green leaf shot by two different cameras will look particularly different on screen when compared side by side. Resolve introduced the color management workflow in version 12, where we have the option of using a color science management scheme. This effectively transfers the color management decision from us to the actual program by remapping each manufacturer's sensor color space into a consistent image reproduction, unified wide gamut working space, and ultimately the final target deliverable output like a Rec 709 or HDR Rec 2020. In turn, this will make it much easier to truthfully represent each camera's unique color science and ultimately shot matching when working with a variety of camera sources. We can set up a scene-referred working environment at the project or node level. They will essentially do the same process but at distinctly different points in the color pipeline. Setting the color management workflow at the project level will let the program choose the color transforms automatically based on each clip's manufacturer metadata and remap those in a wide gamut working space timeline. Since these color space transformations are based on a high dynamic range 32-bit floating point format math, no latitude is lost, as would happen with a technical lookup table, and can be recovered at every point in the workflow. Starting with Resolve 17, Blackmagic Design introduced the DaVinci YRGB color managed system with the DaVinci Wide Gamut preset, which will automatically transform the input color space of your footage to a wide gamut grading environment and an output color space for your footage and use. The DaVinci Wide Gamut preset lets you choose your working and monitoring color space like Rec 709 Gamma 2.4, which applies for the majority of consumer displays. Here I have a timeline with footage from Blackmagic, Sony, Red, and Arri Alexa cameras. Notice how the footage from Blackmagic, the Red, and Arri Alexa cameras are automatically transformed into a Rec 709 standard I have set for my output color space. Footage with embedded manufacturer metadata will automatically be transformed to the output and monitoring color space, which is Rec 709 in my case. Clips with no metadata, like the one from Sony, will need to have the input color space manually specified from the clip thumbnail contextual menu. Working in a wide gamut color space, you're future-proofed for a variety of end uses ranging from the Rec 709 standard for web end use to HDR 2020 or P3 cinema color space without needing to regrade the footage to adapt these output transforms. All you need to do is switch the output color space in the project setting to the standard you need. While the project-level color management is an efficient, one-stop scene-referred solution when working with one source type, we can also use color management at the node level. This method is extremely useful and flexible when working with sources from multiple cameras, and we want to grade them in a unified wide gamut working color space like, for instance, Arri Log C. Working with node-level color management will let us take advantage of clip grouping and subsequently apply the specific color space transforms for each clip source group. This way, we consolidate each group's output transform to match the common wide gamut working color space of our liking. Start by setting your project level management to DaVinci YRGB and timeline color space to RE-Log-C. This will be our working color space and ensures the color-aware tools like the HDR panel to respond correctly. Next, organize each camera source in its own separate group. We've covered clip grouping in our node structure episode. Go to the Group Pre-Clip panel of a group and drag the Color Space Transform tool from the OpenFX list to the node. This will be our Input Device Transform, IDT, transforming the footage source color space into our RE-Log-C working color space. Select the respective input color space and gamma according to the footage source. We can leave the output color space and gamma set to use timeline since this will reference what we've selected at project level, which is an RE-Log-C timeline color space. Set your tone and gamut mapping to none so we can work with the full image data in our pipeline and unselect the apply forward and inverse OOTF. We don't need to do a color space transform of the RE clips since they are already in the color space we've set at the project level. Next, head over to the timeline node panel and add a serial node corrector connected to the input and output, then drag another color space transform on it. This will be our main output device transform, ODT, which will take our unified RE-Log-C color space timeline to a Rec 709 Gamma 2.4 output, ready for our exports and of course monitoring. And since this is happening at the timeline level, it will affect all the other clips groups as well. We can now grade and balance each clip individually on the Clip Node tab, as usual, with the advantage that our footage is already faithfully transformed to our unified wide gamut RE-Log-C working space, making it easy to match the shots from different cameras. So essentially, our workflow is set up with an input color space transform, a working color space, and finally an output transform for your deliverables and monitoring. If and when working with raw clips in our color managed timeline, we need to make sure that they are interpreted correctly according to each camera model because the raw debayering process takes precedence before the input color space transform we have set at the group pre-clip level. We've covered the basics of working with raw footage on our Camera Raw video. Check it out from the link above if you need a refresher. Take for example the Blackmagic RAW footage settings. By default, the decode is set to use the camera metadata. To have it interpreted correctly, we need to change it to Project, where we can specify the parameters manually, which in turn will affect all the raw clips of the same supported manufacturer project-wide. We'll do the same with the red clips and apply the correct decode interpretation. We only need to do this if we are working with raw clips on our timeline. If we only work with compressed clips like H264, Apple ProRes or DNX HQ, we can disregard the raw settings. This whole scene-referred color management workflow might sound convoluted and you might be tempted to ignore it and stick with the more traditional color grading methods, which can work just as fine. But why not take advantage of the color science tools and technology available in Resolve and really make our lives easier instead of relying on shifting variables like our vision, screen calibration, and grading environment? Leave a comment below if you have any questions or suggestions, hit that like button if you find this video useful, and subscribe so you can be notified of each new video we're posting. See you in the next one!